Hi everybody. In this video, I'm going to go through a section that you might encounter when you're going through your Delta Math for this lesson. I think this is called congruence and mapping without coordinate plane. So triangle NOP and triangle NFP are drawn below. If NP is congruent to NP, angle OPN is congruent to angle FPM, which really, notice here that's the same vertex. And angle O is congruent to angle F. Use the drop-down boxes below to determine a transformation that maps NOP onto triangle NFP. Then use a congruence statement to explain why this is possible. So this one kind of has a lot to it, and you might lose sight of what the problem is asking you after you do the first piece. So what we first are asked to do here is to determine a transformation that maps triangle NOP onto triangle NFP. So let's look at what we have here, NOP and NFP. I honestly, if I wanted to turn NOP into NFP, it looks like it has to flip up, right? So let's try a reflection. And then the side that it has to reflect over is that common side NP. So let's try that. Boom. Now that we have that, we can say that triangle NOP maps onto triangle NFP. This is possible because triangle NOP is congruent to triangle NFP by, and then we have the triangle congruency options here, SAS, ASA, SSS, and AAS. And one congruent figure can be mapped onto another using rigid versus non-rigid motions. And hopefully you remember that a reflection is a rigid motion. So the question is here, why are these two triangles congruent? And please remember kind of what they tell us at the beginning. So NP is congruent to NP. Let's see, I need to kind of zoom out a little bit. NP is congruent to NP. So let's mark that here. That's a side congruent to a side. OPN, so let's change colors. OPN, so that is this angle right here. That is congruent to FPN. So same angle, other side. These two angles are congruent. And angle O is congruent to angle F. So here's angle O, and here is angle F. So looking at these two triangles, look at what we have. I have a side, I have an angle, and then I have another set of angles. So this is side angle angle or angle angle side. So these two triangles are related by angle angle side. All right. Boop. I love that. All right, I want to do another one. Come on, give me something fun. I'm looking for something specific. Oh, fine, we'll do this one. Triangle QRS and triangle PTU are drawn below. If QS is congruent to PU, RS is congruent to TU, and angle S is congruent to angle U, use the drop-down boxes below to determine a transformation that maps triangle QRS onto triangle PTU. Then use a congruence statement to explain why. So again, we need to find the transformations, and I hope we agree that QRS really just looks like it's been pushed over, like it just slid right over. So that's a translation. And here, if we don't have a coordinate plane, we just want to make sure the points line up. So point S needs to line up with U, R needs to line up with T, Q needs to line up with P. So I'm going to say until Q lines up with P. Perfect. And then it says triangle QRS maps onto triangle PTU. This is possible because triangle QRS is congruent to triangle PTU by, and then we have those options again, and one congruent figure can be mapped onto another using, and we remember that only rigid motions will produce these congruent figures. So what's the postulate or theorem that allows us to say this, besides the fact that we have these rigid motions? We know that QS is congruent to PU. So let's write that QS and PU. PU, you stink. RS is congruent to TU. RS, TU, and angle S is congruent to angle U. So how do I know these two angles are congruent? Well, I have a set of sides. I have the angle in between two sides that we know. And then I have those other sides. So really, I should have written this maybe over here. Side, angle, side, right? We have side, an angle, and a side in each. So by side, angle, side, these two are congruent. Ah. Please let me know what questions you have on this one. Well, I really wanted to see a rotation one. So I apologize. Please let me know what questions you have still, but let's look at this rotation one really quick. I kind of gave it away that it's a rotation, but if you look at this, I mean, we can't just slide it and it's not a reflection. So this is a rotation. And then it says that we are rotating counterclockwise about point blank. So that means which point is it spinning around? And we're going counterclockwise, so oppositely how a clock spins. We want this shape to match with, wait, which one's the original? Maps XYZ onto DEZ. That's way easier. So XYZ is the original, and it's going counterclockwise. So it's going oppositely how a clock spins. So I hope you notice that these two triangles share a point Z. So that is where it is rotating around. It's rotating about point Z until these corresponding segments should have the same slopes. So ZE, for example. Oh, we're looking at the first triangle. I don't know why I want that top triangle to be the first one. That's the new one. So until ZY, or YZ, the long, long side, has the same slope as EZ. And notice if I mess up, I'm going to select DE instead. It's not going to be quite right. So we want these corresponding sides, YZ and ZE or EZ, to have the same slopes. And then why are they congruent? Based on what's set up here, I didn't even honestly read through this. I was being a little bit lazy. Don't be like me, what I just did. XY is congruent to DE. So we know we have a set of corresponding sides. Oh, look at what I have here. I don't even know if I need to illustrate this. I have a set of sides, I have a set of sides, and I have a set of sides. So this seems like side, side, side congruency. And one congruent figure can be mapped onto another using rigid motions. Again, please let me know how I can help you on this or any of the lessons that we've been working on.